Okay, today I thought I'd talk about the forward reversing mechanical, electromechanical bits that I'm going to use on my little Rudy assembly here. Rudy V-2.5. So I have everything assembled except for the top of the head and the electronics. And again, you can build the simplified version where you simply flip a switch and the robot walks. You don't have to build it with the forward reversing. I already kind of talked about the switch mechanism that I'm going to use down below and the little magnet that latches things in place. And then you see all these wires coming out the top of Rudy's head, and you may be going, oh my god, what's going on with all that? Well, it's really not as bad as it looks. It's really not that confusing. The main red and black that I have my hand on right here, these are from the battery through the switch. So that's my main 1.5 volts. This set of wires, just color code everything as you go along, are simply the wires for the flashing LEDs, so they're going to go to my voltage booster circuit. The two, somewhere in here they are, the two purple wires, those are the switch down below. Normally when this button is all the way forward, they're open circuit. When that bumps into something and the magnet holds it, that's a closed circuit. Very simple little circuit there. And the other wires will be the motor. So motor, LED, battery, switch. And that's mainly what's going on there. Don't you love it when the phone rings? As far as the voltage boost circuit, some of the cheap ones that I like using are like these ones that are sold like this. Now, no one ever have any use for that, so I ended up cutting these off and removing that, and that leaves a flat place on the board where I can mount things, plus the back side of the board is available for mounting things, which is very handy. Your positive and your negative are here. These are inexpensive. You can find them for a little over $1 a piece on Amazon, and don't buy one or two. It's almost cheaper to buy them like in a group of 10 or so. So anyway, I'll snap that off and get down to the bare board, and that's going to give me the boost that I need to change that 1.5 volts up to the 5 so I can run my flashing LEDs. But I also need a way of reversing the voltage to the motor, and that's normally done with what's called a double pole, double throw switch, meaning that there's two sets of contacts out here, and then there's a center one that'll either flip this way or flip this way. So the center contacts are touching these two, or touching the two over here, one way or the other. And you simply, if you're doing the one, it's going to get kind of confusing to explain without drawings. Let's use a drawing. I drew one, why not use it, right? So this is the relay. I'm going to use a 5-volt relay, draws about 30 milliamps, and this is what this is right here. So you have a center contact and an upper and lower one, and that little lever normally is going to be up, and when the coil is energized, it's going to go down. So the switch either is closed this way or closed that way. And then there's another one because it's a double pole double throw, and this one does the same thing. So when there's no voltage applied and both these levers in the up position, I want the motor to run in one direction. When I energize this coil, I want the motor to reverse direction, and you do that simply by taking a set of contacts, opposite poles, bridge them together on both of them. That way when the motor one goes up and down, if it was getting positive, when this goes down, it now gets negative. If that was getting positive, when this goes down, or negative, it now gets positive. So that's how you do it with a relay. It's real simple. In this particular case, this particular relay, like I say, is just a 5-volt relay. Draws about 30 milliamps when it's on. And they have a little diagram which may not show up on the camera, but it's basically showing that these are the common and these are the two outside poles. So this is one set of switches here, and here's the other. These two on the bottom are the coil. Now, because this robot walks so slow, if it bumped up to something, it would get to that point where the switch would be making or chattering or almost breaking. So, not breaking physically, opening the circuit. So that was why I'd added the magnet initially, so that when it did walk into something, I wanted the magnet to complete it and stay latched. So the relay would stay latched, so the motor would reverse and make it very good. But I found that that just changed the resonant frequency of when that breaking and making part happened. It does keep the switch closed, which is a good thing. But what I really needed was a little bit of a delay. Now you could do it the brute force way and just throw like a 1000 or 2000 UF capacitor across the coil, so when that switch closes it also charges the cap, and then it'll continue walking. In this case, I guess the biggest problem is when it's backed up and going to go forward again. It would continue into that motion enough where the switch fully can open or can fully close, depending on which way you're walking. But the brute force method isn't the best way to go. It's much easier just to throw any signal transistor in there. And basically this is an emitter follower, they call it. The collector of the little signal transistor. In this case I'm using an NPN. It's a 2N222. A 3904, those are the two most common signal transistors in America, not in the rest of the world. They've got different numbers for theirs, but they're all the same thing. You're going to have a transistor that's got a gain of 100 or so and can easily handle, in this case, 5 volts, which would be any transistor. So you're just going to tie your collector to the 5-volt rail, and you're going to take that little switch that we made down below, so when it closes it brings the base up to the 5-volt rail, and the emitter is just going to follow it. That's why it's called an emitter follower. So this will become 5 volts. The difference is, why do you go through all that trouble? Well, if you just had the switch turning the coil on, the switch has to handle the full 30 milliamps that the coil draws. And if you had a cap on there in the brute force method, the cap's got to be really big because you're drawing 30 milliamps when the switch opens to get any sort of delay. If you go through something like a transistor that has a gain, let's say, of 100, I'm just pulling that number just so we can have a discussion, you can now go in there with a very small value cap. In this case, I'm going to use a 10 UF capacitor to ground. So when this switch closes and makes that base positive, the current across that switch is going to be 100 times less than the 30 milliamps, so less than half a milliamp, or 0.0 or whatever it is. Very little. You could turn it on by licking your finger and touching across there. It makes it very sensitive. So that means that you can use a very small capacitor to give you a delay. And we don't need to use a bleed-off resistor because I'm using a transistor, not a FET. Transistors are current devices, so that means even though there's 30 milliamps here, that does represent a current draw at the base, so it will in fact discharge that capacitor over time. And that's what gives me about a third or a half of a second or so delay to get rid of the relay chatter. Makes everything work very smoothly. This over here just represents the boost circuit. And this is just the on-off switch, if we keep everything in frame, to the 1.5 volt battery. So remember, the relay is actually switching the 1.5 volts to the motor because the motor is running on 1.5 volts. The 5 volt regulator is just here to run the LEDs, and in this case to power the relay, which is going to perform the forward reverse switching mechanism. So when I made it up, this is where this USB connector used to be. So where that used to be, I stuck on the 2N22 transistor and a small 10 UF capacitor on this side. On the back side, I just glued on that relay we just talked about. And it's not very complicated if you watch the diagram and how you can do it. I've got one leg of the coil going to ground. I've got the double pole, double throw switch wiring going on here. So basically I'm just going to solder this into all this, and with any luck in the next video I should be able to show you this thing operating. Cross your fingers and hope to die.